Hello everyone. Today in this video we are going to discuss about alkyne. Okay. The unsaturated hydrocarbons in which any two carbon atoms are connected by a triple covalent bond are called alkynes. Alkynes is a type of unsaturated hydrocarbons in which any two carbon atoms are connected by triple covalent bond. Okay. Let's start the definition. Alkynes are unsaturated hydrocarbons in which any two carbon atoms are connected by a triple covalent bond. And general formula is CnH2n-2, where N represents carbon atom and suffix is YNA. Suffix is used to determine the given hydrocarbon, whether the given hydrocarbon is alkane, alkene or alkyne. Okay, so every time you remember suffix. Let's go to the example, and here we discuss example. Example: ethyne, propyne, butane, pentane and many more. Okay, so let's move to the structural formula of ethyne, propyne, butane, pentane. Structural formula is most important because when you understand about the structural formula, then you can easily determine whether the given hydrocarbon is alkane, alkynes or alkanes. Okay, so let's draw the structural formula of ethyne. Here, as we have already discussed about the basic terms, that if there is two carbon atoms, we use word root eth. So in ethyne we have used word root eth, so we understand that here is two carbon atoms, so we draw two carbon atoms. And according to the definition, what is here? The unsaturated hydrocarbons in which any two carbon atoms, here remember, here it is, any two carbon atoms are connected by triple covalent bond. Okay, triple covalent bond. So we draw here triple covalent bond. Okay, triple covalent bond, and remaining will be hydrogen, because we know that maximum capacity of carbon to combine with other atoms is 4. So we have gained here two carbons, and in between them triple covalent bond and hydrogen. Definition of alkynes. This is one of the type of unsaturated hydrocarbon. So the unsaturated hydrocarbons in which any two carbon atoms are connected by triple covalent bond are called alkynes. I have indicated here red lines because this one is important in this definition. Okay, any two carbon atoms are connected by triple covalent bond. Okay, and next point is the general formula is CnH2n-2. Its general formula is CnH2n-2, where N represents the number of carbon atoms. N represents here number of carbon atoms, and the suffix is YNE. We use YNE suffix in alkyne. Here we can see examples: ethyne, propyne, butane, pentane and many more. And we have to understand about the structural formula of alkyne, and I am going to take ethyne as an example to draw the structural formula. Okay, in our previous video we have read basic terms that we use word root eth only if there is two carbon atoms in hydrocarbon. Okay, here two carbon atoms as word root is used. Okay, and according to the definition we have here any two carbon atoms are connected by triple covalent bond. So we have connected 2 carbon atoms by triple covalent bond, and here 1 hydrogen and 1 hydrogen, because the maximum capacity of a carbon is to combine with 4 atoms. Okay, 4 atoms. So here 3 atoms of this carbon combined with 3 atoms of this carbon, and 1 atom is combined with 1 atom of hydrogen. Similarly, 1 atom of this carbon is combined with 1 atom of this hydrogen. And let's go through the another example. We take here propane. Here we have taken ethane. Okay, ethane. We take here propane. Okay, if a hydrocarbon consists 3 carbon atoms, then we use word root prop. So we write here 3 carbon atoms, and as per the definition we write here triple covalent bond in between any 2 carbon atoms, whether you write in first, second or second, third. Here let's write here in second, third, no matter wherever you write, whether in first, second or second, third. So write here 3 atoms of this carbon combined with 3 atoms of this carbon, and 1 atoms of this carbon is remaining, which combines with 1 atom of this carbon, and its 3 atoms are still to combine, and they combine with 3 hydrogen. Now this carbon cannot combine more, and this carbon can combine 1 more. So we write here molecular formula 1, 2, 3 carbons. So we write here C3, and hydrogen how many? 1, 2, 3 and 4. We write here 4. Okay, similarly we write here C2 and H2 for ethane. Let's check the formula whether the formula matches or not. Our formula is CnH2n minus 2, where the n is the number of carbon atoms. Let's go through the formula CnH2n minus 2. This is our formula. We put the number of carbon atom is 2. So C2H2 into 2 minus 2. Here we get C2H4 minus 2. That is C2H2. Yes, it is matching. Okay, this one is matching with this. Okay, similarly let's check propane. CnH2n minus 2. We put here 3 as the number of carbon atoms. We put here 3 because there is 3 carbon atoms, 1, 2 and 3, and here H2 into 3 minus 2, and here we write C3H6 minus 2. Okay, and we write here C3H4, which is matching with this formula. Okay, so here we conclude our formula is right. Let's take one more example so that you can understand better. Let's take pentane as an example. Pentane, we write here 5 carbon atoms, because word root pent is used only if there is 5 carbon atoms in a hydrocarbon. But remember here we have connected carbon atoms by single covalent bond. But in our definition here, any 2 carbon atoms are connected by triple covalent bond, means any 2 carbon atoms must be connected by triple covalent bond. So we connect any 2 carbon atoms by triple covalent bond. Here we connect these 2 carbon atoms by triple covalent bond. Okay, and remaining will be hydrogen. Remember this: hydrogen, 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 and this carbon cannot combine with any more. Similarly, this carbon also cannot combine with any more atoms, but this carbon can combine with 2 hydrogen atoms, and this carbon can combine with 3 hydrogen atoms. Okay, 3 hydrogen atoms. So how many carbon atoms? 1, 2, 3, 4, 5. Yes, C5. And how many hydrogen? 1, 2, 3, 4, 5, 6, 7 and 8. 8 hydrogen atoms are there. Let's check it through formula. Okay, and our formula is CnH2n minus 2. Okay, and we write here where n is the number of carbon atoms. Here number of carbon atoms is 5. So we write here C5H2 into 5 minus 2. C5H10 minus 2. C5H8. Okay, and which is matching with this one. Okay, so here we conclude that our formula is right. And in this lecture we have understood about the definition of alkynes, the general formula of alkyne, the suffix we use to denote alkyne, examples of alkyne, yes, structural formula of alkynes, and application of the general formula here. And we have also checked the molecular formula both via structural formula and the general formula. In this lecture only this much. In another lecture we'll discuss about IUPAC system and other topics.